All right, welcome to the deep dive. Today, we're tackling something pretty foundational, I think, for the future of AI applications. We've got a stat of sources here, some intro materials, architectural deep dives, tutorials, even a roadmap, all about something called the Model Context Protocol, MCP.
That's right. And our goal really is to unpack what MCP is, how it actually works, and probably most importantly for you listening, why this kind of technical protocol matters for how you'll interact with powerful AIs like LLMs down the road.
Yeah, we're going to break it down piece by piece. Think of this like explaining a brand new, pretty interesting, maybe slightly complex subject to a room full of curious students. We'll build it up layer by layer.
Exactly. Start simple, add the details, make sure it all connects logically for you.
Okay, so let's start right at the beginning. At its heart, what is the problem that this model context protocol is trying to solve?
Well, you know, LLMs are amazing at processing language, generating text, all that stuff, but they're often generalists. To be really useful for your specific job or with your specific data or inside your applications, they need context. They need access to info or tools that are unique to your world. The problem MCP tackles is standardizing how applications give that specific relevant context to the LLMs.
Okay. Standardizing context. The sources use a really good analogy for this, comparing MCP to a USB-C port for AI apps. Why does that comparison work so well?
It's pretty perfect. Think about it. Before USB-C, you needed like a different cable for everything, right? Displays, power, data, maybe audio.
A little mess.
Yeah. USB-C gave us one standard connector. MCP wants to do the same for AI. Instead of every AI app needing a custom-built way to talk to your files, your databases, your internal tools, MCP provides one standard way for those connections to happen.
Right. It gets rid of that headache of like bespoke connections for every single thing. And the sources mention a few key reasons why this kind of standardization is needed now. It sounds like it helps with building more complex AI agents.
Oh, absolutely. By offering these pre-built standard ways to connect to data and tools, it really simplifies developing agents, AIs that can do complex multi-step tasks using various resources.
And it gives you flexibility. Is that part of it?
Huge flexibility. Yeah. If your app gets its context through this standard MCP way, it becomes way easier to switch between different LLM providers.
Okay.
So you can move from one model to another without having to rebuild all your data connections from scratch. The LLM just gets context via the standard MCP interface.
That's actually really powerful. And what about security? The sources mention security best practices being built in somehow.
Yes, and that's crucial because the data access happens through the MCP server, which you control, and which only exposes what's supposed to be exposed through the protocol. It helps keep sensitive company data or your personal files more secure.
Right, within your own setup.
Exactly. Rather than potentially having to send everything out to some general purpose model somewhere else.
Okay, so MCP, standard way to give LLMs context and tools, offers flexibility, helps build agents, better security.
Got it. Now, how does this actually work, under the hood? The sources lay out a specific architecture like the building blocks.
Let's use that student analogy again. Imagine you're building a really smart robot that's your AI application.
Okay.
And this robot needs little assistance to go get information or use specific tools.
Gotcha. Assistance.
So you have the main robot application itself. In MCP terms, that's the MCP host. It's the program starting the conversation, like maybe a desktop app or an IDE plugin.
Okay, the host. And inside that host, there's a specific bit that knows how to speak the MCP language.
Precisely. That's the MCP client. It lives inside the host app, and its job is to manage the connection to the next piece.
Which are the MCP servers, right? The sources call them lightweight programs?
They are. These are those specialized assistants. Each server is designed to expose certain capabilities or access specific data sources, all using that MCP language. So the servers are the ones actually connecting to the outside world, or maybe your internal world. The sources mention local data sources like files or databases.
And also remote services, maybe external systems out on the internet that the server can talk to through APIs or something.
Okay, so let me try framing this for you listening. Your AI app, the host, needs info from, say, a spreadsheet on your computer, local data source. Instead of the host needing to know how to read every spreadsheet format, it talks via its MCP client to an MCP server that's specifically designed to handle spreadsheets. That spreadsheet server accesses the files securely, figures out the content, and sends the needed context back to the AI host, all using the standard MCP protocol.
Exactly. It's a smart way to delegate. You modularize the capabilities, keep things secure, and everyone speaks the same language.
It delegates those specific, sometimes tricky tasks of accessing and understanding different data or tools to these specialized servers.
Yeah, and they all communicate using that common standardized protocol. That's the key.
Okay, now we see the big picture. Host, client, server, data sources. Let's go a level deeper. How does that connection actually work? What are the more technical layers involved?
Right. We can think about it in layers, kind of like a network stack. First up, you've got the protocol layer.
This is the language part we talked about, the rules of engagement.
Exactly. This layer defines the conversation itself. How are messages framed? How do you match a response to the original request? How does the whole interaction flow? The sources mention key concepts like the protocol object and how the client and server objects at this level manage the connection lifecycle and message handling.
Okay. Protocol layer defines the what and the how of the conversation structure. Below that, there's the transport layer.
This is the nuts and bolts. It's how the messages physically travel from A to B. It's the channel.
Like the pipe the messages flow through.
Precisely. The protocol is the language. The transport is the medium carrying the sound or the data packets in this case.
And the sources say it supports multiple channels, like Studio transport.
Yeah, Studio is simple and really common for processes running on the same machine.
Yeah.
It just uses the standard input and output streams to pass messages back and forth directly. Super efficient for local stuff.
But what if the server isn't local, if it's somewhere else on the network or internet?
Then you'd probably use something like the HTTP with SSE transport. This is built for remote communication using standard web tech.
Okay.
It uses HTTP POST requests for the client talking to the server, and then server sent events, or SSE, for the server sending messages back to the client. SSE lets the server kind of push updates when they happen, which is great for streaming data or notifications.
And the crucial detail here, the thing that makes these different transports actually work together seamlessly, the sources emphasize that all transports use JSON RPC 2.0 for formatting the messages themselves.
Yes, absolutely vital. Doesn't matter if the message travels via Studio or HTTP SSE, the structure inside that message is the same. JSON RPC 2.0 gives that standard format for requests like call this method with these parameters and responses, here's the result, or here's the error, all using JSON.
It's the universal envelope.
Pretty much.
Speaking of messages, the sources break down the main message types that MCP uses based on that JSON RPC standard.
Right, there are four main ones. You've got requests.
That's like asking a question, right? You send a request, you expect an answer.
Exactly. You're asking the server to do something or give you something, and you're waiting for the outcome. If it works, the server sends back a result message, contains the data, or confirms the action was done.
And if it doesn't work, if something goes wrong?
Then you get an error message back. The sources mention standard JSON RPC error codes, things like method not found if you ask for something the server can't do, or invalid params if you sent bad data. And the SDKs can define custom errors too for more specific issues. It clearly tells you, nope, that didn't work and here's why.
Okay. And the last type was notifications.
Notifications are just one-way messages, fire and forget. The sender sends it, but they don't expect any response or confirmation back. It's purely informational, like a status update.
Okay, let me try that classroom analogy again. Request result is like student asks teacher a question, gets an answer. Notification is like the teacher making an announcement to the class, no reply needed. Error is, well, getting your paperback marked up with comments on what went wrong.
Hopefully constructive comments via those error codes.
Right. So how does this whole conversation actually, start and stop? The sources describe a specific connection lifecycle.
Yeah, it's a defined handshake process. Starts with initialization. The client sends an initialized request to the server. It's basically saying, hi, I'm here. I speak this version of MCP. Here's a bit about me.
And the server replies?
Yeah, the server responds with its own info, its protocol version, and critically, a list of its capabilities. What resources can it provide? What tools does it offer?
So the client knows what it can ask for.
Exactly. Once the client gets that successful response, it sends one last initialized notification back to the server, just confirming, okay, we're synced up, ready to talk.
And then the real work begins.
Correct. After that handshake, they enter the message exchange phase. This is where the actual requests, results, errors, and notifications happen, the main part of the conversation.
And how does it end? Termination.
Termination, right. Ideally, it's a clean shutdown. Maybe one side sends a specific shutdown message or calls a close function. But things can also end unexpectedly if the transport connection breaks, network fails, process crashes, or if there's some kind of fatal, unrecoverable error.
And throughout all this, the sources mention error handling is built in.
Yeah, the protocol and the software development kits, SDKs, are designed to handle errors gracefully. We talked about error responses for failed requests, but there are also ways to catch errors at the transport level, like a connection drop, or within the protocol logic itself. The goal is to make sure both sides know when something's wrong.
Okay, that paints a really clear picture of the mechanics. Now, one of the sources we looked at was a tutorial about using this stuff specifically, how you could use an LLM like Claude to help build an MCP server. This feels like taking all that technical detail and actually applying it with a smart assistant.
It does, and the point of that tutorial is really to show how you can use a powerful LLM to speed up the development of those MCP clients or servers we've just been discussing.
So how do you even start using an LLM to build something based on a spec like this? The tutorial breaks it down. First step, preparing documentation.
Right. You've got to give your AI assistant the textbook first. You feed the LLM all the relevant MCP docs, a full spec, the SDK guides, examples, everything that defines the protocol and how to implement it. The LLM needs to learn the rules.
Give it the manual? Makes sense.
Right.
Then what? Describing your server.
Yes, and this is key. You have to be super specific about what you want your MCP server to do. What data sources is it connecting to? What specific resources will it expose? What tools will it offer? What prompts or workflows will it support? The tutorial had a good example.
Oh yeah, the PostgreSQL one.
Right. Building a server that connects to a company database, exposes table schemas, provides a read-only SQL tool, and offers some predefined data analysis prompts. That level of detail.
You're not just asking for an MCP server, you're asking for an MCP server that does this specific job.
Exactly. It's a clear project brief for your AI assistant. Then comes the actual working with Claude part. Yeah. And it's not just, press a button, get code.
No, the tutorial described it as iterative.
Very much so. You start with the core features, get the LLM to draft that. Then you add more capabilities piece by piece. You ask the LLM questions, explain this bit of code. Can you modify it to do this? You get help with testing logic, handling edge cases. It's a real back and forth.
Like pair programming, almost.
Kinda, yeah. And the tutorial pointed out Claude can help implement those specific MCP things. Resource management, tool definitions, prompt templates, error handling, the connection setup.
So it handles a lot of the protocol boilerplate.
That's the idea. It frees you up to focus more on the unique part, the logic for connecting to your specific database or your specific tool.
The tutorial also included some best practices for using LLMs this way.
Smart tips too, like break down your big server idea into smaller chunks first. Test each piece thoroughly. Always think about security validate inputs, limit access, document the code the LLM generates so you understand it later, and crucially, double check that the code actually follows the MCP spec correctly.
Right, don't just trust it blindly. And the next steps after getting that initial code.
You absolutely have to review it yourself carefully, then test it rigorously. The sources mentioned a specific tool for this, the MCP inspector.
I saw that. A dedicated tool for checking if your implementation is compliant.
Exactly. Once you're confident it's working and secure, then you connect it to a real MCP client like Claude.app or another compatible app, and you test it in practice, iterate based on how it works. The LLM can even help you refine the code during that stage too.
So using the LLM is less about getting a finished product instantly and more about having this powerful coding partner to help implement the MCP standard correctly throughout the process.
Precisely. It helps accelerate building those vital connections to your specific world.
All right, so we've covered what MCP is, its structure, how you might build with it using AI, but it's not finished, right? It's evolving. The sources included a roadmap. What's that tell us about where MCP is heading?
Yeah, the roadmap we saw was updated around March 2025, looking about 6 months ahead from then. So plans might shift, but it shows the direction.
And a big focus seems to be validation, making sure things are built right.
Yes, building trust and consistency. They're working on reference client implementations, basically, official examples showing how apps should implement the client side correctly, and compliance test suites.
Automated checks.
Exactly. Automated test developers can run against their client or server code to make sure it follows all the MCP rules.
Like giving out the study guide and the official exam helps everyone stay on the same page.
You got it. Another area is a registry.
To help people find available MCP servers.
That's the goal. An MCP registry, probably starting as an API layer. The idea isn't necessarily one giant marketplace, but to enable others to build discovery services or marketplaces on top of this standard registry API.
Ah, okay. So if you build a cool server, you could list it via the API for others to find through different directories.
That's the thinking.
What else? Agents were mentioned.
Right. As AI tasks get more complex, needing multiple steps, they need better coordination. So the roadmap includes support for agent graphs, ways to define these complex workflows between different agents or steps using MCP servers, and also interactive workflows.
Meaning better human interaction.
Yeah, things like finer-grained permissions, or standard ways for the AI to pause and ask the user for input or approval during a task.
So enabling AIs to string together actions, but also loop you in using this standard protocol, that's definitely beyond simple data fetching.
For sure. It enables much more complex collaborative AI work. Another exciting bit is multimodality.
Going beyond just text.
Exactly. The roadmap mentions working towards supporting additional modalities, potentially things like video, and also improving streaming capabilities, which would be vital for handling that kind of large data or providing real-time updates.
Wow. So potentially an MCP server could feed an LLM context, not just from text, but maybe by analyzing a live video feed. That's a big step.
It opens up a whole lot of new possibilities, yeah. And lastly, they mentioned governance.
How the protocol itself evolves.
Focusing on community-led development and a transparent standardization process, making sure that as MCP grows, the process is open, collaborative, and reflects the needs of the people actually building and using it. Essential for wide adoption.
It really sounds like they're trying to lay the proper foundation for this to become a truly ubiquitous standard.
That definitely seems to be the aim.
Okay, wow. We covered a lot there. We went from the basic why of MCP standardizing context for LLMs, right through the architecture, how to build with it, and even a look at the future roadmap.
And hopefully by breaking it down kind of like we would in a classroom, building it up piece by piece, this maybe complex-seeming protocol is now clearer. The main thing for you listening is understanding MCP helps you see where AI apps are going. They're not just smart chatbots anymore.
Right.
They're becoming tools that need to interact deeply with your specific information, your files, your tools. MCP is the standard way they can start doing that safely and flexibly.
It's that crucial bridge connecting the general intelligence of the models to the specific context of your world.
Well put, yeah.
So let's leave you with this final thought to chew on. Drawing from everything we discussed, especially those roadmap items like agent graphs, multimodality, interactive workflows, what kinds of really new, interactive, deeply personalized AI experiences tied directly to the information and tools you use every day might the standard model context protocol enable in the near future, things that maybe feel impossible today? Think about an AI working smoothly across multiple proprietary systems you use, or understanding context from live video, all coordinated, maybe checking in with you for approval via a standard interface.
The potential is pretty vast when you start thinking about it like that.
Absolutely. Well, that's all for this deep dive.